Hello, this is Dr. Oz. In this video, I would like to talk about forecast accuracy. Once we make our forecast, it's very important to measure the accuracy of our model in historical data. We call this also validation. Validation. We want to validate our model to see whether the model is performing well or not. So, for example, I will show you here a naive if forecasting, and based on naive forecasting, I have here, as you see, 12 weeks of data in my first column, and this is my real sales data. So let's say I am right here at the end of the first week. All I can see is this data point. In naive forecasting, you assume that next periods will be same as last period's real sales. So that's why at the end of second week, all I see is 17 and 21. And I assume that next week, which is week 3 forecast, will be 21. And let's say here, another example, at the end of third week, I can see all these 3 data points, and the most recent sales was 19. So I will assume that next week will be 19 as well. So how do I calculate forecast error? Basically, you look at the real data, you do look at real, which is my second column, minus your third column, which is forecast. So in this case, 21. For this case, 20, let me just use a different color. 21 minus 17 will give you 4. Personally, I don't like to calculate this way. I like to do 17 minus 21, which is negative 4. Why? Because if the reality is 21, and if my forecast is 17, my error is really underestimation, because I underestimated the reality by 4 units. So underestimation, I think, should be illustrated by negative numbers. But again, this is depends on how you would like to create your forecast. But at the end of the day, you know that there will be some positive errors and negative errors. In this case, positive errors are underestimation. These are underestimations. And whenever the number is negative, like this one, this is an overestimation. Okay, so but if I add all these errors up together, like you see here, and take the average, let's say divide by 12. In this case, I have 12 weeks. That will be a problem. Why? Because that will only show me the bias of the model. And in this case, my bias is a positive number. That means that I underestimate the reality. I have some bias, not much, 5 units out of 12 weeks. So on average, if I divide 5 by 12, you will see that 0.4 units. It's not much. However, there's bias. But instead of doing that, I really like to calculate the absolute value of those, because literally positive values and negative values will cancel each other out if you average them. So that's why I use ABS function in Excel, or take the absolute value, negative numbers will become positive numbers. And then now, if I take the average of the positive numbers, then I can see the real error. Another way to eliminate the problem with getting negative positive errors canceling each other out problem, I can take the square of the errors. For example, if I take the square of negative 5, that will give me 25. If I take the square of negative 2, that will give me positive 4. So that will help me. So in general, I like absolute value better. However, the problem with absolute values is that it's harder to calculate absolute values mathematically than working with squares, because for example, if you take derivative of square, it's much easier, because let's say x squared derivative is 2x. That's why in regression, for example, to find the best fitting line, we use, to calculate r square value, we use mean square error, which is based on squared forecast error, MSE, mean square error. Because again, to find the best line, you need to find the you need to calculate so many derivatives. So and derivatives of square terms is much easier for Euclidean distance. Again, this is a little bit beyond the scope of this class, but I want you to know that. That's why this is not redundant to calculate squared error. A percent error is very beautiful. What you do here is that you divide your error by the reality. For example, How did I calculate this? So this number right here could be calculated by looking at the error, which is -2, divided by the real sales, which is 16. And that will give you -2 divided by 16 will give you -12.5%, or in other words, -0.125. And if you take the absolute value of those percent errors, you can average them out without positive and negative numbers canceling each other out. So that's naive forecasting. Basically, you are using most recent data, and I will show you in Excel how to calculate your forecast error using uh, uh, mean forecast error, mean absolute error, mean squared error, and my personal favorite is mean absolute percent error, which is MAPE. Okay, so you can see the formulas of the error calculation here. Basically, look at the real data versus the forecast, and the difference between those two will give you the forecast error for a given period. Mean forecast error is basically just taking the average of the errors, and mean absolute error is taking the average of absolute errors, and mean square error is taking the average of squared errors, and mean absolute percent deviation is calculating percent errors and divided by number of observations, which will give you the average absolute percent error. So that's it for this video. Next video I will show you how to calculate these things, these errors in a data set. Until next video, enjoy business analytics.